Hey guys, so we are here at week 9. We're going to still be talking about like exponents and stuff like that and factoring. We're going to kind of include all of that, but now we're also bringing back rational expressions, so fractions. Okay, so the first thing we are going to do is a little bit of a review. It's multiplying fractions with exponents as well as dividing fractions. I'm sorry, dividing and multiplying with exponents. I'm having a brain fart there. Okay, so we're going to simplify each of these, kind of re-up on some of our rules with exponents. That way when we move on to the stuff below, we kind of have a good idea of it. Okay, so looking at number 1, first thing you do is simplify the two fractions if you can individually. Then from there, we're going to multiply straight across. So 15 x to the 6th, y to the 8th, over 30 x to the 3rd, y to the 2nd. From there, the 15 and the 30 can simplify to 1 and 2. And then you would be left with x to the 3rd, y to the 6th up top. Remember, when you divide the exponents, or when you divide the terms, you subtract the exponents, and that's going to be over 2. All that would be left over in the bottom is 2. Okay, one more problem. Like that, I'm going to simplify the fractions themselves before I multiply straight across. So I'm going to have 3x to the 2nd over 4 times y. Multiply that. This can simplify, so 8x squared over 15y to the 5th is what I'd be left with. Multiply straight across. So then I would have 24x to the 4th over 60y to the 6th. And then from there, you can just simplify 24 and 60. So what can we take out of there? We know that a 4 can go into both of those. We also know what's bigger than that can go in. 6 can go into both of those. And even bigger than that. Can 12 go? Yeah, 12 can go into both of those, right? So we would have 2 and 5. This would be 2x to the 4th over 5y to the 6th. Now, before we move on, I want to show you a different way you could have done number 2. So I'm going to do this in green. Instead of multiplying straight across, and I did show you this before kind of, but we didn't really spend too much time on it, at least I don't think. I would still say go to this step here where you simplified. So I'm going to rewrite that. So 3x squared over 4y times 8x squared over 15y to the 5th. But what you can actually do there is you can cross cancel. So 3 becomes 1, 5 becomes 5, 4 becomes 1, 8 becomes 2. You could have canceled those out. You can also technically do that with the variables, but I think that gets a little more confusing. But I would definitely say that you can cancel out with the numbers. And I think I've showed you that before. Some of you might have already figured that out. But that way it's not as large of numbers when you move on. Then you would have just multiplied straight across to be 2x to the 2nd over 5y to the 6th, which was our answer. And it was just a little less work you might have had to do. Okay? So now we are going to be looking at multiplying rational expressions, so multiplying fractions. But this time they're going to involve polynomials. So we have a strategy that we're going to follow. First, we're going to factor the numerator and denominators of both the fractions. We're going to factor them separately, whether that's GCF, if that's just factoring a trinomial, the British method, whatever it might be, grouping. Then we're going to cancel out common factors from the numerator and denominators, regardless of which fraction they're in. So I'll show you what that looks like once we kind of get into it. And then we'll write the remaining numerator and denominator factors as one fraction. And then I probably should have an extra step there and then simplify, because you might have missed something, so always double check to simplify again. Okay, so let's look at this first problem. Again, first thing we are going to do is factor all of these parts separately. So x squared minus 2x, I can take an x out of there. I'd be left with x minus 2. On the bottom, I can factor that. That's a trinomial. That's x minus 2 times x minus 2. This next one, 2x squared plus 7x plus 3. I'm going to have to do the British method, which is the forced grouping. So I'm going to do that off to the side so it doesn't get in the way of my problem. So 2 times 3, so what multiplies to 6 adds to 7. That's going to be 6 and 1. So it's going to be 2x squared plus 6x plus x plus 3. Force that into a grouping problem. Take a 2x out, so x plus 3. Take a 1 out, x plus 3. So that factors to x plus 3 times 2x plus 1. So that's what I can write over here. I'm going to write x plus 3 times 2x plus 1. Over that, I can take an x out, and I'm left with x plus 3 in the bottom. So that was step 1. I factored everything individually in the numerator and denominator. Step 2 then says, cancel out common factors from the numerator and denominators, regardless of which fraction they are in. So that's just like cross-canceling. You can only cancel if one's on top and one's on the bottom, but it doesn't matter which fraction they're in. So looking at the first one, I have x. Then I want to look in my denominators to see, do I have an x anywhere? I do. I have an x right here, so I can cancel them out. Okay, I have an x minus 2. I can cancel that out with one of the x minus 2's. Okay, over here I have x plus 3. I can cancel that out with one of the x plus 3's. Okay, so then my final answer that I would be left with, I would have 2x plus 1 up top and x minus 2 on the bottom. That would be my final answer. Okay. All right, number 5. Again, first thing you want to do, factor everything individually. So the top one is going to be x plus 3 times x minus 1. X plus 2 just stays. I can take an x out top over here, and it's x plus 2. And then that's a dots problem, so x plus 1 times x minus 1. So then I look to see what factors I can cancel. I have an x minus 1 up top. I have an x minus 1 in the bottom, so they can cancel. I have an x plus 2 up top and an x plus 2 in the bottom, so they can cancel. So what I'm left with then is x times x plus 3 over x plus 1. That would be my final answer. Again, remember, you can't cancel the x's out because it's addition, so you'd need to have an x in everything. Okay? Let's look at number 6. Okay, I was just seeing how many notes we still have left. So you always want to have them written in standard form. Don't forget that. So I'm going to rewrite this as negative x plus 3. Okay, actually, let's wait a second. That's negative x plus 3, right? Which is also the same as negative x minus 3. I can factor that negative out, and that's probably a good idea to do that. Okay, so this is really negative times x minus 3 over, I'm going to have 10x squared y to the 4th times 18x to the 5th y over x minus 3. So the x minus 3's can cancel out. I can take a 2 out of the 18 and a 2 out of the 10. Okay, and if you want to simplify these variables here, you can. I still like to multiply straight across and then do it. That's just me, but that's totally up to you. So negative 9x to the 5th y over 5x squared y to the 4th. So that would be negative 9x to the 3rd over 5y to the 3rd. That would be my final answer. Okay. Number 7. First going to factor, I can take a 2 out, and I'm left with x squared minus 1, which 2 times x squared minus 1 is the same as 2 times x plus 1 times x minus 1, because that's a dots problem. So if you want to do that off to the side and then just write that part, I'm totally fine with that. Then this would be x minus 7 times x plus 1 times, this is going to be x minus 7 times x minus 3, and that's like all over 1. Okay, so then from there, I have an x plus 1 up here, that cancels out with the x plus 1 down there. I have an x minus 7 up here, that cancels out with the x minus 7 down there. So then I'd be left with 2 times x minus 1 times x minus 3, and that's technically all over 1, but you don't need to write that, so that would be our final answer. Number 8. When I go to factor this top piece, it's going to be x plus 6 times x minus 2. This one I can first take out an x squared. So I'm going to have x squared, and I'm going to be left with x squared plus 9x plus 18. Okay, and that factors that x squared stays out, and that would be x plus 6 times x plus 3 times 6x squared over 1. I just write that over 1, that way it's easier to see it's a fraction. Okay, I have an x plus 6 up here, x plus 6 in the bottom. I have an x squared and an x squared that I can cancel out as well. So then I would be left with 6 times x minus 2 over x plus 3. You don't need to write times 1 because that doesn't change anything. All right, number 9. I can factor out a 5 up top, and I'd be left with x minus 4. I can factor out a 5 in the bottom, and I'm left with x plus 3. I can take a 2 out up top, and it's x plus 3, and then the bottom just stays x minus 4. X minus 4 can cancel out with x minus 4. X plus 3 can cancel out with x plus 3. 5 cancels out with 5, and all I'm actually end up left with is 2. 2 would be my answer. Okay? So now we are going to look at dividing rational expressions and simplifying the quotient. So to review the dividing, when we divide by a fraction, you are really multiplying by the reciprocal. Okay, remember the keep, change, flip. Keep the first fraction, change it to multiplication, flip the second fraction. Okay, so I have 3x over 5, that stays. I change this to multiplication, and I flip my fraction. 25 over 6x squared. 3 becomes 1, 6 becomes 2, 25 becomes 5, 5 becomes 1. This x goes away, and I'm just left with x in the bottom. So that would be 5 over 2x. Okay. Number 2, again, first one stays, 4xy to the third over 5 times 6 over x. Only thing that can cancel out are the x's. So this would then multiply straight across to be 24y to the third over 5. Okay, so now we're going to do that, but it's going to be with polynomials. So again, keep, change, flip, and then all the rules are the same. Factor, cancel, write your final answer. So this first one here, I'm going to definitely have to do the forced grouping, the British method for that one, okay? Okay, so I'm going to do this one over here. So what multiplies to negative 210, that adds to 23, and that's going to be positive 30 and negative 7. Okay, so that's going to be 5x squared plus 30x minus 7x minus 42. Force that into grouping, take out a 5x, and I'm left with x plus 6. Take out a negative 7, and I'm left with x plus 6. So x plus 6 times 5x minus 7. So x plus 6 times 5x minus 7 over x plus 7. Change this to multiplication. This is like over 1, so when I flip it, it's going to be 1 over 5x minus 7. 5x minus 7's cancel out, and I'm left with x plus 6 over x plus 7. Okay. Number 5, I'm going to go ahead and start factoring the top. That's going to be x minus 11 times x plus 2 over x plus 8 times x minus 3. Change the sign to multiplication, flip the fraction. X minus 3 over x plus 2. X plus 2's cancel, x minus 3's cancel, and my answer is x minus 11 over x plus 8. Okay, we'll finish the rest of these problems in the next video.